Welcome. So this is the first lecture from Module 0 for Statistics 2. Module 0 is called Module 0 because there is no test on it. Module 0 effectively is a sort of warm-up module where we have two things we'd like to accomplish, one of which is to review some salient concepts from the Statistics 1 course, and the other one is to get geared up and working in SPSS. Nothing that I'm talking about should seem new. All of this, everybody in this course has had a Statistics 1 course. Most of you have had NCC's course, which I used to teach. I haven't taught it very recently because I have a lot of other things to teach. But Statistics 1 typically covers the same topics regardless of whether or not you had NCC's course or a course somewhere else. In the textbook, which is primarily a reference, if you are not recent in some of your intro stats concepts, you may wish to go back and flip through chapters 1 to 6. I know it's a very comprehensive book, so there's a lot in there, but you might want to take a little time and go flip through it. At one point, that was the text for Stats 1, which is why it's still being used in this course. But you're not going to be like super held accountable for like knowing Stats 1 material for Stats 2. However, and I will review things as we need to, but everybody in here should have had Stats 1. And so what Mod 0 is going to do is go through some of the basic concepts from Stats 1, as well as, very importantly, get us up and running in SPSS so that we can do some stuff in SPSS immediately. The first thing I like to talk about is one of the things that's sort of near and dear to me. And I think when you first learn this as a student, you might not appreciate the importance of frequency distributions. One of the things that's super important in data work is, in Stats 1, very often you have this little toy data set with 20 values in it. And I don't really like seeing Stats 1 taught that way anymore, because in the real world, you very typically will have a data set with a lot of data in it. And when you have a lot of data, which, once we get to even 15 or 20 values, it gets to be something that you can't really just look at it. So what you need to be able to do is you need to be able to take your data and summarize it effectively. So a frequency distribution is the first, most basic, and really the most important way to summarize data, because it takes a bigger data set and tallies it down to a smaller, more comprehensible picture of the data. Okay. Frequency distributions also serve as the basis for many graphs. Now, we need to talk about data types, which I'm going to talk about. Actually, let me talk about data types first. So quantitative data and qualitative data. Data in general is in two categories. The first of which is quantitative. The second of which is qualitative. Okay. Quantitative data, this is your numbers. We're quantifying things. Qualitative data is non-numeric for the most part. It can be like numeric in the sense of like an address or a football jersey, but we're not really quantifying something with qualitative data. Okay. This is a number. Okay. So quantitative data can be referred to as discrete or continuous. Those are some buzzwords from Stats 1. Discrete is actually as synonymous as the word countable. Counts and discrete data go together because very often in life we just count things like 0, 1, 2, 3, and there's nothing in between. So typically a lot of data that we collect is like how many toothbrushes are on the shelf, and that will be a countable number because people don't break toothbrushes up into little bits and consider parts of toothbrushes for the most part. Continuous data is your data that is measurable and can effectively be measured using the real number line or some subsegment of it. This is your height and your weight and variables that the data is such that you have a distribution where there's an infinite number of values and there's no gaps between the values. Okay. So that's quantitative data. For a lot of statistical purposes, it doesn't really matter whether you're talking about discrete or continuous. Like we can summarize either one with basic statistical metrics. When you talked about data distribution, though, that does become the discrete and the continuous do become different because the discrete, when you look at a distribution of discrete data, it's bars with no gaps, whereas continuous is the curves. So that was part of stats one, is reviewing how data is distributed. Now, qualitative and non-numeric data is a whole different world because we are not, we can summarize and work with this. However, we can't do computations, like we can't calculate a mean on qualitative data. So qualitative data is actually of two types as well. The sort of narrative data, which as psychology majors you're probably very interested in. This is like your case studies, your medical records, your psych notes, whatever. Um, this is actually something that in data analytics is called unstructured data, and we can break that up and actually work with it now, which is relatively novel because previously we didn't do that much with it, just wrote it down and then people read it. But there's also categorical, and this is your shorter qualitative data. This is like your color categories and your basic verbal descriptions. Things are not that are not going to be written in sentences, but in a word or a few words. So this is pretty easy to work with in terms of summarizing it. This is kind of a whole different beast. So that is your main types of data. Quantitative and qualitative is the biggest split, and then within quantitative, there's discrete and continuous. And within qualitative, you can think of it as categorical and also larger narrative data. Okay. So for frequency distributions, we can summarize all kinds of data. Typically, not really the narrative data, although there are techniques for breaking that up and doing text analysis. But categorical data and then discrete and continuous data can be summarized with frequency charts. I use the term chart, table, and distribution kind of interchangeably. So here's two examples from the Blumen text regarding frequency distributions. On the left, we have, this is blood types. This one is a qualitative categorical variable, blood type. And so somebody had some data they collected and they recorded how many were type A, and that was 5, and then type B, and then 7. This is the classic old, without even a computer, just doing little check ticks for accounting for things. And so we have the frequencies, that's why it's called a frequency table. And then we have also the percents. Now, the percents are if there's 25 total, there's 5 of type A, and so you have 5 out of 25. That is how you get the 20%, which is listed there, and that should be something familiar to you. And you should be able to convert fractions to percents as well. So this would be a complete frequency table. We have the frequencies and we have the percents. The percents are also called relative frequency. Okay. These also form basis for a lot of people would do a bar chart on the frequencies or a pie chart on the percents or relative frequencies. Okay. So that's a basic frequency table on a categorical variable. On the right, we have a basic frequency table as well, but this, if you look at it carefully, it's got this class limits thing. This is actually one that came from continuous data originally. Okay. I don't have this actual data, but so there was data that had values from 56 to 106, and so whatever these things were, there were all kinds of values in between. But when you have continuous data, it's very difficult to do a frequency table just with the original values in it. So what you do is you bin them, and these are called bins, and so you have to group things together to make it like a summary and not just a big humongous table. And we're going to see examples of that in SPSS. But this is what frequency tables do. Now, this one doesn't have the percents calculated, but you could do that. You have 1 out of 50, so this would be 2%. Typically, these days, computers are used for everything, but you still should understand the conceptual foundations of where these come from. Okay. Here is an expanded, this is just the blood type one again and the percents again. Percent, relative frequency, and also probability are the same thing. Now, probability, this would be the empirical definition of probability, which comes from relative frequency. We don't really deal with probability theory per se, by the way, in stats 2. There's stuff in stats 1, like you spend at least some time on probability. We don't do like probability paper problems in this course. Um, so here you have the frequency table with the categorical variable, the counts, and the percents, but you also have this additional cumulative percent column. Now, this column honestly doesn't really interest me a lot for most applications because what it's telling us is that the frequency of type A plus type AB is 36%, which is just adding up to percents. Um, it doesn't really have a lot of like empirical meaning for a lot of analytical purposes. Occasionally, if this is like an age table and these were age categories, like we would care about the cumulative frequency like up to a certain age, and then we could actually use that for something, but this in and of itself isn't super informative. Except the cumulative percent always should be 100% at the end of a table. Really, the value in these, I'm old enough that a long time ago I used to teach everything by hand because that's what there was. So when you did your frequency table by hand, you always wanted your check for the cumulative percent to be 100, and then you know you did everything right with your math. Okay. Um, a histogram is the visual pal of the frequency distribution. So here we have another frequency distribution, and it's a table. I mean, it's a table. But, and then we have the same exact thing in what's called a histogram. Now, histogram kind of looks and smells like a bar chart. They're really not quite considered the same thing. A bar chart would have the bars separated. A histogram has the joined bars. You can see they're not that. Histograms very specifically are graphs of frequency distributions. That's what the definition of a histogram is. Yes, you could also do a bar chart on the same data, but specifically a histogram is graphing the frequency distribution, and they're very visually handy for looking at how the data is distributed. You can see this one is pretty close to a symmetric normal distribution, not quite, but it gives you a really good way of using just your eyes to check on how data is distributed. You can kind of see this from the table, but realistically, the graph is just a whole lot better. Okay, so now we're going to do our first SPSS lesson, okay? And that's going to be frequency tables and histograms. Now, you will have on Canvas links to the shorter tutorial videos on the specific task. However, I also, for both the remote and the live class, will very often redo a similar or a different demo with the same concept. So you'll actually it'll give you a couple more examples as well. So to complete this video, I'm going to go into SPSS and I'm going to do the frequency table as well as the histogram with various types of data. Okay. So I have here on my desktop a data file. Now this is going to be available to you in Canvas. Everything's going to be available to you in Canvas in some fashion. A couple data sets, I just binned them all together and put a dump file on top. That's because there were so many of them. Listing them independently was kind of a pain. But like sometimes like this one, I'm just going to put it right in your Canvas area along with this video, like bike rides data. So you're going to have this file here. Now this is an SAV file. That is SPSS was proprietary file type. I don't know if we can actually see anything from here. Yeah. So if you click on the file properties, you'll see it's a .sav. I don't know exactly what S, A, and V stand for, but .sav is the proprietary file type of the SPSS software, and these are data sets. Now, these files cannot be opened in other software. So if I give you like an SAV file, it's got to be open in SPSS. And I very intentionally am going to give you SAV files in most cases because I want to make sure you have SPSS. I don't want you to open these in Excel. I want you to open them in SPSS. So I have SPSS installed. They should by default, like your SPSS should be set up like this, so you should be good. But all you have to do to start up SPSS if you have an SAV file is just click on it. I don't have SPSS running yet on this computer. It's going to open when I click on the data file. And sometimes SPSS will be slow. I got to tell you, it's really old software. So I double clicked on the data file and it opened the data file for me, and you can see there's this byte data. I have a giant repository of data sets. To be honest, I don't know exactly where. A lot of them are actually mine from my own work, and a lot of them are also from Kaggle, which is a public repository for data, and a lot of it's government data. So I don't always know exactly where I originally got this from, but it was legal to get it. I'm sure of that. So anyways, this is open in SPSS, and you're like, oh my God. So in SPSS, um, I have to, I only use SPSS now when I teach this class. I've used it extensively in my lengthy life for other things, but um, so sometimes I forget like the specific like what things are called, but this is like the data part of SPSS. And there's two tabs. One is the data view, the other one is variable view. Variable view is really like a data catalog that lists all the variables and like what data types is sort of the technical information. I don't want to like I want to start jump starting you and just using SPSS, and like kind of like as we go along we'll sort of fiddle with some of the stuff as we need to. But so in data view, it's literally what I mean, it kind of looks and smells like Excel. It's actually, it's very different. The layout's the same. It's your row column data format, meaning every row is like one observation and every column is the variable. But SPSS is different and more complex from Excel. And it's highly specific for doing analytical work, not whereas Excel is like for storing data and, just kind of general stuff too, accounting. People do not do accounting in SPSS. I love accounting. It's not to knock accounting, but this is not accounting software. Um, Anyway, so this is this bike data, and you see there's a variety of different variables. There's some time variables and some categorical variables and start station and end station. And then there's this bike ID. Now, these are numeric, but these would be considered categorical. So one thing you might want to do, I don't want to get too into this, so I'm kind of like being a hypocrite and showing this. You might want to actually change this to like nominal data type. Nominal, by the way, is SPSS's categorical variable. That's called nominal data. So when you see this measure of nominal data, nominal and scale, I should have pointed this out. Scale is your quantitative, and nominal is your categorical. SPSS has kind of like the old school social science slant names, but that's what that means. So, and on the top of these little things, like these tell you what kind of variables. There's only two of them. There's like the little circle thing. That's their nominal slash categorical. And then the little measuring ruler things are your quantitative variables. So there's a bunch of different variables in here. This isn't your analysis paper, so you're not really like looking at the actual content of the variables. We just want to play with some of the features. But you see here, there's some categorical variables. So we want to learn to do some frequency tables, and then we want to do a histogram. So let's do our frequency table on this. This end station name is a categorical variable. These are all categorical. Like this one, oh, month. Well, month technically is two. Season that. See month. You know, month. Well, it's actually good here. Like birth year. This kind of really is categorical. So you probably would want to change this because you don't really do like descriptive stats. Like you don't want to do like a mean birth year. That doesn't really mean anything. So sometimes a variable can be numeric, and it's really something that's a categorical variable in nature. And SPSS sort of just sniffs things. This is something I did import from Excel initially, so the setup of the variable types I didn't fix. If I were doing research with them, I would actually sit and do more work, but I really just want to get to doing some frequency tables. So let's do end station name. On the top is your menu. Analyze is going to be the one we use the most. Notice it has some little doohickeys and stuff. We're going to play a little bit with those. But analyze is where all the statistics are for the most part. And so analyze descriptive stats is when we're going to play a lot with this first module. Because this is kind of like where a lot of your basics from stats 1 can be done. So descriptive stats, frequencies. Now this is one that's nice and obvious. Not everything in SPSS is, but this is a good start. Descriptive stats, frequencies. Okay. So when you get your frequency table, sometimes it will be smushed a little. I don't know. Last time it came smushed, now it comes like this. So you can actually play with this a little to refit. The reason you would want to do this is like your little like frequency things here. Like you might not be able to like read the whole like label, and you're looking for a variable and you can't find it. So you can kind of like play with your mouse cursor, or whatever, and like stretch it a little. So I'm looking for end station name, which is right here. Good. And then I'm going to select this. Now you have to do this little selection arrow and then go over. You can select multiple ones at once, but don't make your life too complicated. Um, so I just want to do this one first. So I'm going to do the end station name and click OK. And very nicely, it basically just automatically generates a frequency table for me. So that's really good. This is kind of long. You might want to, I mean, this data, I don't know how to bin because I don't even know what this is. It's like train stations or something weird like that. But it is a frequency distribution on a categorical qualitative variable, and it's very easy to do these in SPSS. Again, you go to Analyze, Descriptive Stats, Frequencies, select the variable, hit go. You're good. Okay. Now, a subtle thing that you may or may not have noticed is that when I did the frequency table, it takes me out of this data view, and then watch. So I go here, and then I am going here, and it's pulling up essentially what is basically a separate program. I don't know, SPSS has like two heads. So like this is like the data part, and then all of your analytical output is here. Now, when you do your homeworks for me, previously what I had people do is save these output files, and then I actually collected these output files. That was a nightmare on my end. So what I'm going to have you do this year is you're going to actually just like, I think you're going to be able to like copy and just paste directly in Canvas. I don't know. I haven't tried it, so I probably should. Is I only want like what I'm looking for. So if I'm looking for like this frequency table, I want you to copy this, paste it in Canvas. And there's directions on all the assignments saying like submit this, submit that. So that's what you're gonna send me for like your grading. And yes, on your first assignment, there is something kind of like this, like make a frequency table. So that's a frequency table on a categorical variable. There's a couple other ones in here, like we could run one on season. You go under Analyze, Descriptive Stats, Frequencies. You got to look for the variable like this. Now here's where you might want to, you can unselect this and move it back because that was the last one. I don't really want that anymore. And then you go and look for seasons. There's seasons. Let's select that. Now all you got to do is hit go. There's other funky little options. We're not going to talk about that yet. There you go. So now this is a wicked simple little one. Very, very nice because you would not in a million years want to go through 20,400 rows to do this by hand. So it's a lovely thing to be able to click a button and get that nice frequency all summarized for you. Okay. So I'm not going to save this. But now what I want to do is look at some quantitative variables. Now age would be a quantitative variable, so let's go for that. Analyze, Descriptive Stats, Frequencies. Again, get rid of your old variable. You don't want extra output unless you really do want extra output. Go for age, and then hit go. Okay. Now, age, even though humans only have a finite lifespan, this is a pretty big table. And the reason is age is actually a discrete variable. So, but you probably, if you're doing an age distribution, you probably want to do some binning. Okay. So you probably don't want to leave it like this. You probably want to do some like 20 to 30 kind of category things and do that instead. Okay. So one thing you want to do is like create age groups. Now these are actually created for you because in this data, they kind of lovingly have already created this age group variable. So this data and this data are really the same data. When you bin it though, like if I didn't have this initial variable age and I just had the summarized data, I would not know sort of like the details from the data. So when you start binning things and grouping things, be aware that you are losing some of the detail. Usually you want to make sure you keep your original data and make sure that you're not just summarizing it and then throwing away your original data. That would not be a good practice. Some of you are probably going to be doing psych dissertations at some point, and so sort of grounding you in sort of basic practices from day one is a good thing. Like, if in doubt, don't throw it out. Hey, that rhymes. So anyways, age groups is the bin version of age. So we can look at this. Let's do, oops, I didn't mean to hit that. Go to Analyze, Descriptive Stats, Frequencies, and then now I can either keep my original or do that. So we're going to age and then age groups. And then that, and then the frequency table on that. And you can see this is much more summarized and compact than doing the age with the original variable. Okay. So I'm not going to save this, but you are. Now you can, and I recommend that you do. I don't really care how you actually manage your own files. I mean, that's sort of your personal proprietary style. But you can actually save these output files and then you could reopen it in SPSS. There is also programming code in here. I don't think many of you are super interested in that. but there is like a programming language. So like if you're doing a dissertation, doing things repeatedly, you can actually write code to program things and run them kind of automatically. I used to do a lot of that kind of stuff in SAS. I haven't really coded a lot in SPSS. Usually in SPSS, I've used it as point and click like I'm doing now. But you can actually save. You can do file save. These are called SPV files. Again, I don't quite know exactly what that stands for, but you can save all these output files. I would definitely save the data files. You don't want to start throwing those away. Um, you know, especially when you're in the middle of an assignment. And a lot of you're going to start getting comfortable in SPSS. On the test, some of the tests are going to be like, I'm going to give you a data set. Obviously, you're going to need to know how to get it into SPSS and stuff. Other tests, you're going to be doing a little bit of data entry. So there is a little bit of sort of like grunt work data entry. And we're actually going to see a bit of that in a minute. Now, how did we get from this age to this age groups? Because if you had to do this manually, it would be kind of a nightmare. Like you'd have to sit there and like group everything and like type this in. But there's a little bit of a trick to this. Now this one is a little bit, I'm like I said, we're gonna get up and jumping. This is a little kind of like a little bit of a technical thing in SPSS. So pretend I don't have this age groups column. Pretend it's not there, and I want to take age and I want to make groups out of it. So I go to this transform and I go to visual binning, go to transform and go to visual binning. I think I'm teaching you one way of doing it. There's probably other ways, but this is like how I know. So transform visual binning. And then I'm going to select the age. And then I get this like kind of weird thing. Which this is actually the distribution of ages, by the way. And what it's basically doing is, this is actually kind of old school. I mean, SPSS has been around for like, oh God, a long time. But this is like the distribution of the ages. They go from 22 to 90. It does actually give you that nice summary. But what you want to do, and you actually have to create another variable. Now, in this case, it was actually already created. Just pretend it's not there. So we're going to create another one, age cat 2. Age bend or something like that. Okay. And it automatically creates a label for us, which is interesting because it doesn't name it. I don't know. I didn't, the way this is set, it's what SPSS does. But so we do that. And then what we want to do is make cut points because SPSS wants us to tell it like how it's going to group these things. Now, let's just be lazy and do like 22 and then like 10 cut points. And then I think it will automatically do, okay, yeah, it will automatically do that. So the width is like 6.8, which is kind of a dumb width. We should probably do like 10. And then it will actually fill in like the other thing. Now, this you couldn't see it, but okay, 22, and then 10, and it's going to fill in. It's going to automatically fill in, I think it is, maybe, yeah, see, it's automatically going to fill in number of cut points. Okay, so that's good. It's automatically grouping our stuff for us. Yay. Okay, so let's do that. Let's do apply. And then you're like the existing cutting. Okay, that's fine. I just want to. And then you see these little bars. So this is our new little bin things. They're not like, I'm not doing this in a really great way. I'm just showing you how to do it. If you're really doing this, you have to like kind of like think about the details of exactly how you want to bin and stuff. So it's got these little bars. These work great. Now, very importantly, you want to click make labels because if you don't, you're going to get like weird coding numbers and not like a nice bin thing. So right here, I mean, the way that I group them isn't great, but it's just kind of random. Anyway, so right here, make labels, people, make labels, okay? Because if you don't, when you hit go and it's going to generate a new column with the new categorical age thing. If you don't do the make labels, you're going to get some weird looking output. And for now, you don't want that. I'll explain what that is later, but right now our goal is to get a bin frequency distribution. So hit go, and then it's going to create one variable, which basically means it's going to nicely create a new data column for us. Yippee. Hit OK, and you get here somewhere a binned age column. So this is the new one. The old one was probably better, but somebody else created that, not me. So this right here is your new age bins. So that is how you can go from a continuous quantitative variable to a binned derived variable from it that you can use for a frequency chart. Again, you go under transform and you go under visual binning, and really you just kind of play with it. And then it will generate a variable for you. And now we have a bin variable that I can go under analyze, descriptive stats, frequencies, and then we get rid of that because that's the old one from somebody else. And now we have our new one, and we can look at it and be like, hey, cool, we got a binned age frequency, just what we wanted. Okay. And so that is your first that's your first SPSS lesson in the frequencies. Now, but wait, there's more. There's histograms. Histogram is a graph of that table. You would think that you could just do it from here, like analyze descriptive stats, frequencies, but I don't think you can. Oh, you can! Wait, histogram. I didn't know you could do this. Let's just do it this way. I thought we had to do another feature. So you can actually just check off histograms and continue. Let's see what this does. I think it's going to work. And hit OK. Yes, this is all we need. We're good. We're perfect. Let's not do anything else. So this is the graph. Now, in this case, it's of the bin data. So, for the histogram, to some extent, this is kind of controversial looking if you think about it too much. But anyways, this is a graph of the bin data. Now, you might also want to look at a graph of the original, a histogram of the original data. So you could go back and do like age, and then do like analyze, and then descriptive stats, frequencies. And then in this case, what I want to do is just the original age variable. I do generally clear out the variables. Rather, you can just like add a bunch together, but then things get kind of dizzy. And then I go to charts, and then I go to histogram and hit go, and I get this. Okay. Now this is much more detailed than the bin one. So kind of for the histogram, you want to look at this region. Like you might look at this, and I can automatically see there's something a little funky right here. Like there's way too many of them this age, but that's deriving like some information from this. There's something that looks a little like non-random about whatever's going on there. But anyways, to do the histogram, let's just review this again. Okay. So we worked with analyze, and then we do descriptive stats and frequencies. That's the only button we've played with so far. So everything's under there. And you go to frequencies, and if you need to, you can create a derived variable to do a bin variable with that transform thing. This also is in the other videos for the specific task. And then you could do like anything you want, like temperature. Now, temperature, if you go to charts, oh, it does a histogram. Technically, we don't really do histograms and categorical variables, by the way, but I guess SPSS is cool with that. Oh no, because this is considered like it is numeric. So here's your histogram and your frequency table on temperature, because I just checked the charts and checked the histogram, and we do get this. So that is your first SPSS lesson, friends. Frequency tables and histograms. All right, that is the end of Mod 0 Part 1. Thanks.